Hello students, welcome back to my channel. The next algorithm what we will be learning is hash search. So in order to understand hash search as an introduction, today we will be learning about what is hash and everything about hashing. So let us go ahead and start. So this session is we will be talking about introduction to hash. So it is going to be a guide for what is hash table, what is hash function, what is collision in hashing, and what are the different resolution techniques we will use in order to do the hashing. So let us start. So first and foremost, what is hashing? As we can see the definition here, hashing is a technique that transforms data of any size into a fixed size value called hash code. It is like creating a unique fingerprint or for your data. So this hashing, mainly what we are going to do is any kind of a value, whatever value which you can call it as a key, we are going to apply certain kind of a hash function and we will generate a hash value. This hash value we will use as an index in the table. Okay, so this will become an index and this is the key what we will have. So with the help of this index, we will be able to access that particular data. So that is what I meant when I say it is a technique that transforms data of any size into a fixed size. So if at all my size is of a 4 byte or a 8 byte, so I am going to convert any kind of value into that using the hash function. And that particular value is called as hash code. So what are the key characteristics of this? It converts all the keys into array indices. So that's what I said, index or indices. We are going to convert all the keys into indexes. And it gives us order of one average case lookup. When I say that, it is going to be a constant. The value for the average case lookup is going to be a constant that is order of one. That is reason being when I have an index, if I have 1 to 10, if at all I want to access a particular value, say 5, I know where exactly 5 is lying. So it is constant. It is not going to vary. Okay, and it is a one-way transformation process. We are going to transform key into the indexes. It's a one-way transformation and it is widely used in databases and cryptography. Databases and cryptography where you have to convert the key values into a particular index. There we will use the hashing techniques. All right, so this is your hashing. So next, let us see what is a hash table. So all the values which we have converted will be stored in the form of a hash table. So a hash table is a data structure that stores key value pairs. So we'll have keys as well as we'll have value. Just now we saw a table where I'll have a keys and value. This is called as hash table. All right. So it uses a hash function to compute the index. The index is computed using the hash function into an array of buckets. It provides incredibly fast access. With the help of this key or indices, what we will be able to do is we will be able to access the data. So the structure of the table, an array where each index can store one or more key value pairs. That is what the structure is going to be. So we will have values and keys as well as values. The performance, once again, it is going to be order of one time complexity for insertion, deletion, as well as search. So if you want to insert, you know exactly where you need to insert. If you know delete, also you know where exactly that particular value is present. And even if you are searching for that, also you know that where it is present. So it is always going to be order of one. And the applications are going to be dictionaries, caches, symbol tables, and database indexing systems, just like how we discussed. These are the application. It is going to be of hash table. Now, let us see one real world example. So phone dictionary implementation. Here, if you are storing the context where names are the keys, and phone numbers are values. For example, if Rajesh Kumar is a key value and the value which you want to store is uh, the mobile number belonging to Rajesh Kumar. So what we are going to do is we are going to apply particular hash function for this particular key, which is the name. And then we have generated a certain number called as 42. Now in a table, I will have 42. In front of that, I will have the number which belonging to the person, Rajesh Kumar. So whenever I want to look for that Rajesh Kumar's number, I know that it is stored in the value 42. Similarly, Priya Sharma, it is stored in 15. Now you may ask, how did we generate this? So we'll discuss that what are the different hash functions. So here the hash function is important. What are the different hash functions we can use in order to convert the given value into the index? So this is one of the example. So what is hash function? So let us go ahead and see what is a hash function. Now, a hash function is a mathematical algorithm that converts input data into indices. Just now we saw that input data was the name, and then we got a certain value like 4215. That is nothing but the indices. A good hash function distributes key uniformly across the table. So, how much ever your value may be, your hash function should be good enough to get those many values. So, if at all I am storing n number of values, your hash function should generate keys which should be unique across the table. Okay, so input key will be any data type. It can be string, number, or object. And hash function is going to be any mathematical computation. It can be a mathematical computation that is nothing but a hash function. So when you give input, any kind of input into this mathematical function, it is going to generate an output. That output is nothing but the index into the hash table. I hope it is clear. Okay. Then we have hash code, fixed size numerical output. This hash code is nothing but this output of this particular mathematical function, which you call it as index also. This is going to be of fixed size. It has to be fixed size because it will be used as an index in our hash table. So it cannot exceed whatever may be the input value. This hash function, the job of this hash function is to convert that into a fixed size output. And array index is nothing but the position in the hash table. Array index, for example, if the array is starting from 0, 1, 2, 3, that is nothing but the position of this hash code in that particular hash table. All right, I hope it is clear what is hash function and what are the different features of it. Now, let us see the common hash function which will be used. So first one is a division method where the table size indicates that how many number of rows are present. That can be, for example, number of rows of a hash table can be the table size. For example, if it is 10, so every key value I am going to divide it by 10. Okay, so see here, if key value is 127, when I say 127, here mod is operation used 10. Now mod, I hope all of you know the difference between the division and mod. Now, unlike division, the mod always gives us the remainder. All right. So 10 divides 127 120 times, and the remainder is 7 as in 12 times it divides 127 and the remainder is 7. So 7 is going to be the output. So index generated here is 7. Okay, this is called as a division method. There is another thing called as a multiplication method. If you see here, m into key into a mod 1, where a is approximately 0.1 is 0.618. It is called as a golden ratio. Here we are going to use this particular value. Okay, so this is also another method we can use. There is also called as a mid square method where square the key, extract the middle digit. So if this is the key, square of 52 is going to be 2704 and the mid value of this 70. So 70 is going to be the key. Or there is also called as a folding method. What we will do is, if this is my key value, I am going to add 12 plus 34 plus 56. The total is going to be 102. Then 102 mod table size is going to give us a key value. So any one of them can be used as a hash function. Not just these, there are many more. These are just the example I gave. The very common one, what you will see across is, especially in the textbooks and all, it is a division method where we will simply find the key value mod table size. This will give us the key value. All right. So that is what the common hash functions are. Now, once we know that what is a hash table, what is a hash function, how does it work, there is also a problem associated with this hashing that is called as a hash collision. Now, hash collision occurs when two different key produces the same hash value. That is, for example, I have a table. I applied certain hashing method, and suppose 1, 2, 3. I have filled this table, and next when I applying the hash function, it is once again generating 2, which means I need to store over here. But already there is a data present in this. So that is where a hash collision occurs. So that is what when I say when two different keys produce the same hash value, attempting to occupy the same array index. So you are trying to occupy the same array index which is occupied by the already existing one. This is inevitable due to the pigeonhole principle. We will call it as a pigeonhole principle where we are trying to occupy data in a single available space. Okay, what is the reason for this? One is limited table size. Your table is very small and you have many data to store here. That is where it might be happening. Poor hash function distribution. The hash function which is being chosen is not so very good that it is repeatedly generating the same values and similar input pattern generating the same hash. Probably you are trying to give an input. For example, if the hash function which you have used the division method and the table size is 5 and constantly you are giving 20 as an input, obviously it is going to generate the same value. Okay, so these could be the common causes for hash collision. Now, how do we get over it? So, resolution techniques, there are multiple resolution techniques in order to overcome this collision. First one, we can call it as a chaining, where what we are going to do is each table slot contains a linked list of all the element that hash to that index. For example, like the previous example, I have 1, 2, 3. These are all already filled some data. Now, once again, I'm getting another key value to the same. That time, what I will do is I will do the chaining. Chaining as in I will create another memory space and I'm going to add over here. So again, if I have, I will do the chaining. This is called as chaining, where I'm going to create a chain of linked list and I'm going to store those particular value in the same index. Okay. Next one is called as a linear probing, where search sequentially for the next available slot in the array. So I got 2, but 2 is already filled. Then I will move to the 3, then, but 3 is also filled, but 4 is empty. So what I'm going to do is I'm going to store my new value in 4. This is called as linear probing. That is, I will apply the hash function and suppose there is a collision which is happening due to some reason, then I will go to find the next empty space and I'm going to store my value there. That is called as linear probing. What is quadratic probing? Quadratic probing is the same thing as linear probing, but here we are going to find the square of that alternative slot. Okay, for example, 2 means 2 to square, so 4. If 4 is free, I'm going to store that. Suppose 4 is also filled, then 4 square, which is 16. I'll go to 16 and see if it is free. So that is not nothing but quadratic probing. And double hashing. Double hashing is nothing but if I'm applying certain hash function and if I'm coming across a collision, then I will use one more hash function. That is a different hash function in order to find out the next slot where I need to store it. That is called as double hashing. Okay, so these are the basic common collision resolution techniques which we will use whenever we apply a hash function and we end up in a collision. So that's all in today's session, students. So these are the fundamentals of hashing. In the coming session, we will learn about hash search. Now that we have learned what is hashing and how we can store the value in case if there is a collision. In next session, we will see how can I search for a value in a hash table. So thank you for watching. Keep learning.